Hey physics enthusiasts, I'm Swati and welcome back to my series on mechanics. Right now we are learning vectors and this video is all about numericals based on vector. This is a part 1 video and we'll do some more video numericals in the next lecture. So let's begin with that. Okay, so the first question is find the angle between the vector this and this. So to determine the vector, you can use either the scalar product or the vector product. Here we are using scalar product. Simple. So using scalar product, you know that cos theta is equals to A dot B over magnitude of A, magnitude of B. So first you can calculate what A dot B. So A is 2i cap plus 3j cap minus k cap. Dot product with I cap minus j cap plus 2k cap upon magnitude of A, that is 2 square plus 3 square plus minus 1 square into magnitude of B, that is 1 square plus minus 1 square plus 2 square. Then this become 2i cap into I cap is 2, 3 into minus 1 is minus 3, minus 1 minus 2 is minus 2 over 2 2s are 4 plus 9 plus 1. This is 1 plus 1 plus 4. So this become minus 3 over under root of 14 and under root of 6. Okay. So either you can leave here or you can solve the denominator term and you can solve it by taking it combinedly and factorize it. So 14 can be written as 2 into 7 and 6 can be written as 2 into 3. So this become minus 3 over under root of 2 can be taken out. Wait, I write it more space. So this become minus 3 over root 14 and root 6. And if you take it combinedly, 14 can be written as 2 into 7 and 6 is 2 into 3. So you can take 2 to be out. Then it becomes minus 3. 2 can be taken out and 7 3s are 21. So the theta become cos inverse minus 3 to root 21. That sounds. Okay. The next is determine the projection of a vector A onto this. We have already done a lot of questions based on this projection thing. So you have to determine the projection of this onto this. So the projection of A or vector A can be determined as A dot B, and you have to take the magnitude of that vector onto which the projection is. Okay, so it is like this. So first you can calculate A dot B, that is I cap plus 2j cap plus 3k cap dot product of 3i cap minus j cap plus k cap and the magnitude of B vector 3 square plus minus 1 square plus 1 square. So that becomes 1 into 3 is 3 minus 2 plus 3 over 3 3 is a 9 plus 1 plus 1. Then it becomes 4 over 11. So 4 by root 11 is the projection of A onto B. Okay. The next is, if A cross B is equals to 0, then show that A and B are parallel. Now, if A cross B is 0, then A cross B, oh, here I can just mark it. Okay, so this A cross B can be written as magnitude of A, magnitude of B, sine theta, that is equals to 0. Now, if A and B are two non-zero vectors, are two non-zero vectors, that means magnitude of A is not equals to 0, magnitude of B is not equals to 0, then definitely sine theta is equals to 0. And sine theta 0 is when theta is either 0 degree or 180 degree. That means A and B vector are either parallel or anti-parallel. Parallel or anti-parallel. So it's like this. Okay, the next question is, find the area of a triangle formed by the points this. So you have point A, B and C. A is 1, 2, 3. B is 4, 0, 1. And C is 2, 5, 3. So from here you have to calculate this AB vector first. And then you have to calculate this AC vector next. So AB can be found as B minus C. Oh, sorry, B minus A. And B minus A is what? 4 minus 1, 3 I cap, 0 minus 2, minus 2 j cap, 1 minus 3, minus 2 k cap. And then a C vector, that means C minus A. C is 2 minus 1 is I cap, 5 minus 2 is 3 j cap, and 3 minus 3 is plus 0 k cap. And basically the area of the triangle is what? The cross product of these two vectors. So first we calculate the cross product and then we take the half and get the area, because area of triangle is half of magnitude of their cross product. So first we calculate their cross product, which is equals to, first we write I cap, j cap, k cap, and then first the coefficients of AB, that is 3, minus 2, minus 2, then it's 1, 3, 0. If you solve it, it become I cap. Minus 2 to 0 is 0. 3 into minus 2 is minus 6. It become plus 6. Then minus j cap. 300 plus 2. Then k cap. Let's see, 3 is 9. And minus 2 is plus 2. So this becomes 6 I cap minus 2 j cap plus 11 k cap. And then you can calculate the magnitude. Its magnitude would be 6 square plus minus 2 square plus 11 square. And it become 36 plus 4 plus 121, that is equals to 40 and 161. So from here you can say that its area is half of under root 161 square units. That is the area. Okay, so you have to calculate the cross product and then you have to take its magnitude. Okay, now next question is, a vector C is such that A plus B plus C is 0. A plus B plus C equals to 0. You have A and B, you have to find C. So C is basically what? Minus of A plus B. It's a very simple question. Just put the value of A and then B and simple solve it. It's minus 1 plus 2 is 2 I cap. You can simply add the coefficient. It's I cap and plus j cap and minus j cap. So it will be 0. So C simply, sorry, this is 1 plus 2 is 3 I cap. So C vector is simply minus 3 I cap. It's straightforward question. Next, find a unit vector perpendicular to these two vectors. If they need a perpendicular vector, then you have to find what? A C vector, which is a cross product of A and B. Only then it is perpendicular to both A and B. Then calculate A cross B. This A cross B is I cap, J cap, K cap. A is 1, 1 and 1. B is 1 minus 1 plus 1. Solve it. I cap is 1 minus minus plus 1, then minus j cap. This is 1 minus 1, then plus k cap, and it is minus 1 minus 1. It become 2I cap. This term will goes to 0 and become minus 2 k cap. So this is your A cross B. Now you have to find a unit vector. That means you have to find C cap, that which is equals to C vector upon its magnitude. So this is 2I cap minus 2k cap, and just take its magnitude. It's 2 square plus 2 square. That is equals to 4 plus 4, 8, and 8 can be written as 2 root 2. So if you take 2 to be out, it becomes I cap minus j cap over under root of 2, which is a unit vector and perpendicular to both A vector and B vector. Okay. The next is, okay, so the next question is prove that magnitude of A cross B is equal to the area of the parallelogram formed by vectors A and B. So for that, formed by the vector. So if let's say this is one side of parallelogram with vector A, this is the other side B. This could be taken as also B and this as A. Okay, so these forms the four sides. Now let's take first these two sides. Now let's take the angle between them is theta. Now if you resolve this B vector perpendicular and along this vector, here you have B cos theta and this is your B sin theta. As per the resolution, we have already discussed that in our previous videos. So from here you can see that what is the area of parallelogram. Let's say the parallelogram is this A, this B with one more side and here sides, and mark them as A, B, C, D. Okay, so the area of parallelogram A, B, C, D is what? Base into height. Base is what? This AB, and height is what? This, let's say this is PA. Now your AB is A vector, magnitude of A, and PA is what? B sin theta. That is magnitude of B sin theta. And from here the area comes out to be AB sin theta without n cap, and that is what? A cross B, and it's without any direction. Without direction, that means it is the magnitude. So this is the magnitude. So area of parallelogram is calculated using the magnitude of A cross B. Next question is find the vector cross product of this and this. It is simple cross product. A vector is 2i cap minus j cap plus k cap, and your b vector is I cap plus 2j cap minus k cap. And to calculate cross product a cross b, simply first you can write I, j, k, then 2 minus 1 plus 1, then is 1 plus 2 minus 1, and just take the determinant. First write I cap and then multiply these two terms, that is minus 1 into minus 1 is plus 1, minus plus 2 into plus 1 is 2, then minus j cap, it is minus 2 minus 1, and it is k cap, which is 2 to the 4, and minus 1 minus minus plus 1. So this goes to be minus I cap minus 3 minus minus plus 3 j cap and plus 5 k cap. So this is the cross product of these two vectors. It's simple. Okay, a straightforward question. Next is determine the volume of a parallelepiped formed by vectors this. Okay, so to calculate the volume of this parallelepiped, what you have to do, its formula is A dot B cross C, and it is same as to prove this is the formula to calculate the volume of parallelepiped. So to calculate volume, it is A dot B cross C. Okay, and if A dot B cross C comes out to be 0, then this is the condition of coplanar. The vectors are coplanar. So just remember these two identities. If this is equals to 0, then all the three vectors are coplanar. And just to calculate the volume of the parallelepiped, you don't have to make it equal to 0. Just calculate A dot B cross C. So first, we'll calculate B cross C. Just put I cap, J cap, K cap. B is this, that is 0, 1, 1. C is K and I, that is 1, 0, 1. Then it is I cap, which is 1 minus 0. Then it is minus J cap, which is 0 minus 1. Then it is K cap. Which is again 0 minus 1. This comes out to be I cap minus minus plus J cap and minus K cap. And then calculate A dot B cross C. So A is I cap plus J cap, and B cross K comes out to be I cap plus J cap minus K cap. I into I is 1, J into J is 1, K is not here, so K is 0, then it means 0 and 2. So the volume is 2. Volume of parallelepiped is 2. This is the answer. Okay. Next question is verify this vector identity. Okay. So basically you can verify this by taking some values of A, B and C and then putting here, and then you can verify that. The second is the basic mathematical algebra, that if you open it, you can do it. So just solve it using some assumptions for A, B and C, if you want to prove it theoretically. Okay, but just you can remember that this. Okay, so this is much for this video, and this is a part 1 video, and we'll do some more question in the next video. Till then, do like, share and subscribe and comment below for your all queries and anything you want to know. I will explain you any topic, any question, anything, any doubt. So do comment, and thank you for watching this video once again, and we'll meet you in the next video.